Hello, I welcome you all in this presentation related with the subject failure analysis and prevention. And in this subject, we are talking about the fundamental sources of the failure, and we have talked about various sources of the failures. And in this presentation, we will be talking about the failures which are occurring due to the poor assembly, poor service conditions, and the poor maintenance which is carried out during the service. So, we will be starting with the poor assembly or assembling related issues. Improper assembly, poor assembly are related issues. So, we know that for making any system, it is required that number of subcomponents are brought together. For this purpose, we may use various joining approaches like mechanical or there may be thermal approach. Mechanical approach involves the use of nuts and bolts, rivets, etc. In thermal, it may be brazing, shouldering, welding, and but at the same time, the two components when brought together, they must be kept in proper position, and they should maintain the relative movement as per requirement. But if the assembly is not proper, then the different subcomponents which have been assembled will not remain in their positions, as well as it is also possible that the relative movement, whenever it occurs, the relative movement also is not controlled properly. So, most of the assembly related issues or poor assembly related issues are encountered in the components where relative movement exists between the different components. So, the main sources for the main sources of the failure due to the poor assembly includes ambiguity in instructions, like for assembly, assembling is done in particular way. So, the proper procedure has to be developed for assembling purpose. So, if the procedure for assembly is not clear, this is one, then it can lead to the number of things to the judgment of the person who is assembling the things. The second one, if the assembly procedure is not clear, or the procedure insufficient procedure, means whatever the procedure has been developed is not enough or not proper, insufficient or inappropriate procedure of assembly, then also it can lead to the failure. Then another point is related with the misalignment, because especially when the two components are having the relative movement with respect to each other, or if the two components are joined together in such a way that the alignment is crucial for transfer of the load from one side to another, and if that is not maintained, then it can lead to the unbalanced application of the forces and the stresses, and that can lead to the failure of the component. So, misalignment, especially in the shafts and gears, this kind of the misalignment becomes the main source of the failure. And then poor workmanship, if the operator who is assembling the different component, if he is not doing the things carefully, so poor workmanship. Sometimes accidentally also, like a workman is careful, but accidentally if he is missing something to be placed in a proper place, then those accidental errors also sometimes accidental errors on part of the operator or the person who is assembling the things can also lead to the so, this is placed as inadvertent errors, not the intentionally carried out errors. So, more efforts need to be put in, like well thought out procedure for the assembly is developed, and then if the proper procedure has been developed, it must be made clear, like who will be doing, what will be done by whom, how it will be done, when it will be done, like that. So, well thought out procedure has to be spelled out, or it has to be mentioned clearly, and misalignment has to be avoided, especially when the relative movement exists between the two or more components, and poor workmanship is to be avoided through the proper training and awareness program of the operators, so that they can be more motivated towards the work and follow the instructions given for the assembly. So, these are some of the general points which are observed whenever observed as reasons for the failure due to the poor assembly. This is one of the cases wherein we can see the failure of the engine took place due to the inadvertent error on the part of the operator. So, in this case what had happened, like the breakdown of the air compressor engine, which was was made from the 4-cylinder engine. This engine actually broke down with the fracture of the piston on the connecting rod end side, and the assembly, when the system was opened, it was found system was opened for examination. It was found that that the failure occurred of the two connecting rod bolts used for the joining of the piston and connecting rod. So, basically the failure occurred in the nut and bolt which were used for joining the connecting rod with the piston, and one bolt one bolt did not show any mark of the wear, like here we can see these were the two nut bolts which were used for assembling the piston to the connecting rod, and when the system was opened for examination, it was found that one of the bolt had the wear marks on its surface, while another was fractured. So, it was observed that the two nuts were present in one of the bolt, while another bolt was free from any nut. So, this is what also can be seen. So, since the bolt A did not had any nut, so it was free during the operation, and that is why there was a lot of relative movement between the between this bolt and the and the piston, which caused a lot of wear marks on the surface of the bolt. While in other cases, since this was free, so it was not taking much of the load, while another was which was having the two nuts, which was having the two nuts. So, this was the only one which was carrying the load, and since this was sharing the load, see, this was taking the load of the system completely, and another one was not sharing the load. That is why it fractured under the this is what we can see, and this also led to the stretching of the thread and some of the crushing of the threads onto the bolt, and this end also can be seen that it was damaged. So, here it was found that this actually the nut was inadvertently tightened in the same one, and other one was the bolt was left, another bolt was left without nut, and that is why it was free to move. So, this is the kind of error which which occurs inadvertently, not knowingly. So, this is one of the example where we can see inadvertent error on the part of the operator takes place. Likewise, there can be number of situations where failure occurs due to the improper procedures. We know that in cars, the wheel when the wheel is assembled, the tightening of the nuts is done in a very particular sequence, and if that sequence is not mentioned properly, sequence is not followed, then we may find that the nuts may get loosened and subsequently the wheel may come out during the running of car itself. So, it is important that how much torque will be applied for tightening purpose, and what will be the sequence of tightening of the nuts in case of the cars, and likewise the different sequences must be maintained whenever the assembly is prepared. This is another example where the failure of the gear occurred due to the misalignment, and in this particular case what we can see here, misalignment will be leading to the increased contact in one side and another and the non-contact in another side of the gear. So, the gear is having like two sides, this is one and this is another side, this is the width of the gear. So, misalignment will be leading to the increased stresses and the increased load in one side of the gear, which will be causing the higher rate of the wear in one side as compared to the another. This also can be seen from the temperature rise. It is expected that temperature rise in the two sides of the gear is not, temperature difference in the two sides of the gear are not much, and if it exists, that is also used as an indicator of the possibility of the misalignment. So, misalignment will be leading to the non-uniform distribution of the stresses along the width of the gear, and which will be causing the increased wear rate in one side as compared to the another side, and that in turn will be leading to the increased wear rate in one side. So, similarly there can be lot of examples for where failure occurs due to the misalignments in case of the shaft and couplings, when the two shafts are coupled using the coupling, and if they are not properly aligned, they will be causing a lot of stresses during the operation, and that can lead to the failure of coupling or the failure of shaft subsequently. So, a proper assembly procedure has to be developed, and that is to be followed for avoiding any failure due to the improper assembly. Now, the next is that poor service conditions. We know that whenever a component is designed, that is designed for a particular set of the service conditions. These service conditions include lots of variables which may be in terms of the load for which component is being designed, like the type of load, rate of loading, the magnitude of the load, that is the maximum load that can operate onto the that can be applied during the service onto the components, so magnitude of the load, and likewise many load related parameters. Similarly, the temperature, it will be the normal ambient temperature, it will be the low temperature, there will be limit like say minus 20 degree centigrade or minus 60 degree centigrade for which component is to be designed. Similarly, there can be high temperature conditions, it is 200 degree centigrade or 600 degree centigrade as per the application, and accordingly the component will be designed, a suitable material will be selected, it will be heat treated accordingly so that it can perform the required required service. And then apart from the temperature, there can be environment which may be like in form of like dry environment, or it is the moist environment, or it may be like sea water, it is to be designed for sea water, or it may be corrosive environment like hydrochloric acid or NaCl, like in case of the sea water, or the liquid metal, like number of components are used in contact with the liquid metal like zinc and magnesium, etc. So, the resistance of the component has to be checked against those environments, and then accordingly it has to be used. And if it is kind of a special conditions, then like wear, for which kind of wear it will be subjected, like adhesive, abrasive or erosive, cavitation wear, etc. So, these are some of the examples for which these are some of the service related things for which component will be designed. So, what we do basically, we estimate the failure mechanism, and based on this we select the suitable design criteria, suitable material is selected, and then it is manufactured, and after manufacturing we put the component into use. So, each component which is designed for a particular set of service conditions must be used in those conditions only. If the component is not used for those service conditions, then it can lead to the undesirable and unexpected performance, even premature failure of the component. So, what we can see here, if the component is exposed to the service conditions for which it has not been designed and fabricated, then it will lead to the premature failure of the component. One of the simplest example for this can be like this: one QNT steel, quenched and tempered steel, which was quenched and then tempered at 400 degrees centigrade for one particular application, where service temperature is say 300 degrees centigrade. But if the same one increased with the performance, if the same one is used for the 400 degrees centigrade, then there will be possibility that whatever the steel which was quenched during the exposure at 400 degrees centigrade, it will be over tempered. Over tempering will do simple thing, it will cause the softening, loss of strength, loss of mechanical properties. So, their ability to take the load will be reduced. So, if the steel has been quenched and tempered at particular condition, then it should be used for the temperatures below those tempering temperatures, otherwise it will be over tempered. Likewise, if a steel weld joint, like say the mildly steel weld joint, which is normally designed for say normal ambient conditions of the temperature, like say up to minus 20 degrees centigrade, and if it is exposed for the temperature conditions even further lower, then it will lead to the significant drop of the toughness at low temperature, and the component may not be able to survive under those conditions. So, it is important that the component is used for the conditions for which it has been designed. If it is exposed to some other set of the conditions, then this will simply cause the premature failure of the component. So, some of the conditions here which has been mentioned, like which may be considered as the poor service conditions, means the failure of engineering components can occur due to the abnormal service conditions for which it has not been designed, and these abnormal conditions may appear in form of abnormal high rate of the loading. We know that if the component has been designed using the tensile parameters, tensile test as a tensile properties like say yield strength and ultimate strength, which are conducted under the very low strain rate conditions like this. So, strain rate conditions are say very low, maybe like say 0.1 or 1 mm per minute, and but if it is, so that is showing the behavior under these conditions. But if it is exposed for like say 10 mm per minute or 100 mm per minute strain load conditions, then it will be showing the different kind of behavior. It will be showing much higher strength but reduced ductility. So, the behavior of the material changes with the rate of the loading. It tends to behave more like a brittle material as compared to the more ductile material at a high rate of the loading. So, since the behavior of the material changes with the rate of loading, it may lead to the premature failure under the unfavorable high rate of loading conditions. Similarly, unfavorable oxidative wear, unfavorable corrosion conditions and erosive environment. So, these are the service conditions. If the component is exposed for these conditions for which it has not been designed, then it will be leading to the premature failure. Similarly, the high and low temperature conditions for which it has not been designed can also lead to the failure of the component. This is one typical example where one ship which was made of the medium carbon steel, which did not have much low temperature toughness, when it hit the iceberg at under the low temperature conditions. So, because of the low temperature conditions, it had lost its toughness, and hitting with the iceberg led to the fracture of the ship from the middle in the two parts. So, that fracture was primarily caused by the failure of the rivets which were used for joining of the ship. So, the change in temperature conditions also can lead to the failure of the component. So, the operation in the conditions of the abnormally severe in respect of the speed, loading, temperature, chemical environment, and absence of the regular maintenance. These can lead to the failure of the component, premature failure of the component. So, normal inspection and maintenance during the service therefore must detect what is the tendency of the component to fail by a particular mechanism. So, during the inspection it is required that we are in position to check whether it can fail by a particular estimated mechanism or not, and if it can fail then we need to do the suitable repair and the maintenance, and if it is not then it is allowed for the regular service. Now, there is one case study where during the service itself the boiler tubes during the service exposure of the boiler tubes led to the failure of the tubes prematurely. So, we know that startup of any new system is important, and normally in the new, when the component is new, it is subjected to the somewhat lower stress conditions, lower service conditions as compared to the normal service conditions. So, we can see here startup is critical for the complex components, and intermittent operation after the maintenance, intermittent operations to deal with the extreme temperature gradient and other abnormal conditions. So, the thing is, when the component is new, it is exposed for the reduced load, reduced temperature, reduced aggressive environmental conditions in the initial stage of the service, so that the component can really get used to for those conditions especially in the initial stage, and once it is placed in the service then it needs regular maintenance. But for the regular maintenance we need to take the shutdown, and proper shutdown procedures need to be followed. So, in one of the situations what had happened, like the boiler tube, boiler having lot of reheater and superheater tubes. So, one of the superheater tubes showed the leakage during the trial test after the regular shutdown maintenance. So, the pitting corrosion in the superheater tube, the case study is related with the pitting corrosion in superheater tubes of the boiler during the several annual shutdown when it was taken place. So, actually the boiler, for the details if we go, the boiler tube failure, the failure of the boiler tube here, say these are the superheater tubes, and these started leaking during the trial run, and the trial run was conducted after the maintenance during the hydrostatic testing of 15-year-old boiler showed the leakage in the superheater tubes, and these tubes were operating at 400 degrees centigrade at 700 psi. So, the tubes of the 15 mm in diameter and 4.12 mm thickness had been in service for past 9 years at this much. So, expected life was this one 15 years, but during the service during the service of the 9 years, it had worked successfully at 650 psi and 400 degrees centigrade. So, after the maintenance it was in trial run at 400 degrees centigrade and 700 psi. So, what it was made of, medium carbon steel was used for making the superheater tubes, which was having the wall thickness of 0.165 inch, that was about like say 4.12 mm and 5 mm 50 mm size of the tube diameter, and this was the arrangement. And for regular maintenance of this system, annual shutdown used to be taken, and during that the maintenance was carried out. And what had happened actually in this case, the regular maintenance annually was carried out for the 9 years, and during the maintenance period they used to open it up and then they will clean it up properly, and then thereafter then after the regular maintenance they will put it on the trial run, and then after the successful trial run it used to be operated for the normal operation. So, the tube is in this zone started leaking, and it was found that after since the leakage in the superheater tubes started, so they wanted to investigate what led to the failure of the premature failure of the superheater tubes. So, the tubes were cut, and it was found through the visual inspection that black adherent magnetic scale with the localized presence of powdery loose. So, both type of the black and both types of the oxides were found, black adherent magnetic scale with the localized presence of the powdery loose and non-magnetic black scale. So, the powders of both magnetic and non-magnetic type, one was adherent and another was loose. This was found on the internal surface of the tube. Analysis of these oxides by XRD showed that Fe3O4 black iron oxide powder and Fe2O3 the red dust like the powdery form, and the iron oxide without chloride. So, this was important to important for the inference that there was no effect of the chlorides which is normally added in the water for the softening purpose. And the metallography of the superheater tubes also showed that the carbon steel is the carbon steel has the normal structure of the ferrite and perlite, and there is no segregation and heterogeneity. After this analysis, it was observed that absence of the chloride showed that no SCL effect used for cleaning of the tubes, because the SCL was being used for cleaning of the tubes and remove the dust and the rust. Fe3O4 formation suggests the presence of the oxygen is limited for the pitting, and Fe2O3 formed the loose powdery non-magnetic brown deposit, suggests the pitting caused by the presence of the excess oxygen and which was observed in normal moist corrosion pits which were there. And history revealed that during the shutdown, 15 days annual overhaul for requisite repairs was carried out, and during this shutdown period itself the oxygen rich condensate caused the pitting in the lower points in the bend region during the overhaul period. So, this was the reason, like during the shutdown the oxygen used to get dissolved with the water which was getting segregated at the bottom of these tubes, and this was the main reason behind the pitting at the lower bends of the superheater tubes which were located here, and that is why under the pressure during the trial it started leaking from these locations. Now, the last point is about the poor maintenance strategy. It is important that the clear and well thought out maintenance plan is developed, and it should clearly mention that what will be done for during the maintenance and when it will be carried out, and where it will be done, who will be doing, and how the maintenance will be performed. Everything needs to be specified very clearly, and if the things are not mentioned clearly, so any lack of the information on proper schedule of maintenance, procedure of the maintenance, it can lead to the premature failure of the components, especially the moving components, where the lubrication is important for reducing the friction and reducing the wear of the components. So, this is one typical example wherein spline end of drive shaft 4350 steel drive shaft failed prematurely, and this shaft failed after 700 to 900 hours of the service, and the shaft which was made of the 4350 steel had the hardness of the 34 to 38 HRC, and this was case hardened to the HRC for to this level of the hardness after the case hardening for 48 to 50 minutes, and the depth of the hardening was 7 80 micrometer, and the counter surface against which the shaft was used had the hardness of the 58 to 60 HRC, and this was coated with the counter surface was coated with the molybdenum sulfide. This is the solid lubricant coating, and the spline shaft you can see here, this is the spline and shaft, and this this spline actually failed due to the wear, and this was investigated. The cross section of the spline shaft showed the presence of the number of oxide particles at the bottom, and this led to the modification of the tooth profile. The tooth original profile was like this, but after the service it worn out significantly, and it lost this much amount of the material from all the tooths. So it was indicating basically the presence of the wear, and a lot of it was indicating the loss of the material occurred due to the wear, and the presence of the oxide debris also suggested the removal of the material by wear. So observation suggested that oxide debris at the root area. There was no residual lubricant on the spline shaft. Magnetic particles showed no surface defects. Chemistry and metallography of the spline shaft showed the results as per the expected and specified one, and so it was concluded that failure occurred due to the excessive wear due to the breaking down of the lubricant. Since the lubricant was not found on the surface of the tooth, so it was found that actually lubricant was absent, or it was not maintained properly during the maintenance. So the recommendation was that lubrication after each 300 hours, and it is also important that hardness is increased from 4853 HRC to the 58 to 63 HRC. So once if this was implemented, thereafter no premature failure of the spline shaft was observed. So now I will conclude this presentation. In this presentation I have talked about the three aspects related with the fundamental sources of the failure. One was improper assembling procedure. Second one was the improper maintenance, and the third one was the improper service conditions. So if the component is exposed for the unfavorable conditions, then it can lead to the improper premature failure. Thank you for your attention.